Hello, this is Mr. Stansbury. I'm going to take you to the last section of Chapter 11, which is the last chapter in the first year of IB studies. Yay! So anyway, this is on 11I, harder applications. The goal on this is to be able to say that I can use various formulas and strategies to solve more difficult real-world type problems. And I'm going to show you just one example, but it pretty much puts together this entire chapter with a whole bunch of different questions on the same piece here. So this is example 2. This is actually number 2 from page 390 because they didn't actually give us any examples to go through. So this is number 2 from the assignment, or from the book assignment here anyway. And it says a feed silo is constructed out of sheet metal that's 3 millimeters thick. And it says show why the depth, or the height in this case, of the cone must be 70 centimeters, and then find the slant height of the conical section. Conical section just means this here, the cone piece of this silo. Okay, so first thing we want to do is start trying to figure out what these dimensions are here, because we got to be able to show that the height of this cone here is supposed to be 70 centimeters. So let's kind of draw some more. Let's draw this a little bit more three-dimensionally here. So if you were able to see through this, it would look kind of like that here. And they're saying that we want to know that this here, this height here, has to be 70, 70 centimeters, not meters. Right? So, let's see. We will want to figure out what this is here. This is this top piece here is, I didn't really draw it very beautifully, but it's supposed to be a half of a sphere. So if it's a half a sphere, oops, this radius here, which is apparently crooked, that's alright. This radius here should be half of this diameter, and we know the diameter is 1.6. So really what we're going to want to do is take 1.6 and divide it by 2, which gives us 0.8 meters. So we know that this diameter here is 0.8 meters, which is, if we move the decimal over twice, it turns it into 80 centimeters, right? Okay, let's stick with 0.8 for now, but we'll use the 80 here maybe in a little bit. So we have this from top to bottom, it's 3.3 meters, and we know that this piece is 1.8. So we can do this. We can take 3.3 and subtract 1.8 to get 1.5, and that's this piece and this piece. We just figured out that this is 0.8, so if we take 1.5 minus 0.8, that leaves us with 0.7 meters, and 0.7 meters, they say that it needs to equal 70 centimeters, and guess what? Meters to centimeters, move it over twice to the right, and we get 70 centimeters. So we have now shown why the depth, or the height of this cone, must be 70 centimeters. And now, since we know that, find out what the slant height of this conical section is. So basically they're saying figure out what this length right here is. Okay, so again we have this here. We know that this is a right angle. So let's see, we know that this here is 0.8 meters, this is 0.7 meters. So if we're to redraw just that piece there, we would have that this is crooked, but that's alright, you're used to it by now. 0.8 meters, and this is 0.7 meters. So we should just be able to do a squared plus b squared equals c squared, right? So 0.8 squared plus 0.7 squared should equal this hypotenuse, or the slant height, squared. Alright, so we turn on our calculator, and 0.8 squared plus 0.7 squared gives us 1.13. And then we just want, so we got c squared equals 1.13. So then we will square root both of those and get that our slant height is square root our answer, and we get 1.06 meters. So let's go with that. 1.06 meters is our slant height for this here. Okay, so we have finished off A. Let's take a look at B. It says calculate the surface area of each of the 3 sections and show that the total steel needed is about 15.7 meters squared. Excuse me. So it's at least nice because they give us the answer in there, just saying make sure that you can get that all figured out, right? So let's see. We have the 3 sections. We've got the half sphere here, we have the cone here, and then we have the cylinder here. So I don't know about you, but I think I'd rather let's find the cylinder first. So, and again, you can do it however you want, but the surface area of a cylinder is basically, if you think about it, you cut the cylinder, like just snip it, like think of it as a tin can, snip it down here and open it up, flatten it out, and that surface area is going to be the base here, which is basically the circumference. So surface area is the circumference times the height, or the surface area circumference is 2 pi r times the height. So our surface area of just this piece here is going to be 2 times pi, and again we know that the radius of this thing here is 0.8, and we know the height is 1.8. So bring out our handy dandy calculator again, and let's see what we get. 2 times pi times 0.8 times 1.8 gives us 9.05. Let's go with 9.05, and this is all in meters, so meters squared, so that's just for this part of the can here. And now we're going to need some other formulas here. One of the formulas is for the cone here, and that says area equals pi r times s. So pi times the radius times the slant height is going to be the surface area of this cone. So this is the cylinder part. Alright, now we're going to do the cone part. And then the surface area of that is, again, pi times the radius times the slant height. So pi r times s. So in this case, surface area is pi times, let's see, the radius again is 0.8, and the slant height is 1.06. So we use our calculator here. We do pi times 0.8 times 1.06, and that gives us 2.66 we'll go with. And that is also square meters. Alright, and then next thing we're going to have to do is find the area of this half sphere here. And so we need to know the area of the sphere. Area of a sphere, and again that says minus, there's supposed to be another little line there, equals 4 pi r squared. So the little half circle thingamabobber here is going to be, since it's only half of the sphere, let's do half of 4 times pi times the radius squared. So in this case, we get half 4 times pi, and then again the radius is 0.8 squared. So the surface area on this one is going to be 0.5 times 4 times pi times 0.8 squared. Alright, and that gives us 4.02 square meters. Alright, so to figure out the total surface area, we just add all 3 of those together, right? So total is going to be 9.05 plus 2.66 plus 4.02 2. So let's try that out. 9.05 plus 2.66 plus 4.02, and we get 15.73. 15.73 square meters, and we were supposed to show that it's supposed to be 15.7, so we know we got that one right. That's a doozy. That's a good question. That is certainly not something that's really easy. You got to take little piece by piece and go through and solve that. All right, let's move on to C. It says show that the silo would hold about 5.2 cubic meters of grain when completely full. Okay. So with that, we're going to need some volume formulas, and this is back from the volume section. So uniform solids of uniform cross section here is this here. So basically the can, the cylinder part here. So we've got the cylinder. The volume is going to equal the end, which is the area of the end is going to be pi r squared, and then we multiply it by the height. So in this case we have pi. We know that the radius was 0.8 meters, and then the height, let's double check here, the height here is 1.8 meters. Right, so 1.8 meters, and this 0.8 meters is squared. So we turn that on. We take pi times 0.8 squared times 1.8 for our height, and we get 3 points. Let's go with 3.62. 62 cubic meters. So that's for the cylinder. For the volume of a pyramid or a cone, it's just 1/3 the area of the base times the height. So let's go with the cone piece here. Right, and then the volume there is going to be 1/3 the area of the base, which is pi r squared times the height. Okay, so volume equals 1/3 of pi, and again we remember that the radius is 0.8, and then the height was 0.7 meters, if you'll remember that. Remember that's actually what question A was asking us to do, is show that the height was 70 centimeters, which is 0.7 meters. Okay, so turn our calculator back on, we calculate that one, we get 1 divided by 3, let's see, times pi times 0.8, and this was squared, and then times 0.7, right? And that gives us 0.47. So volume equals 0.47 cubic meters. And then the last part is the sphere. So and then again, this is just the half sphere. Right? The volume is going to equal, and this is 4/3. So we're going to do half of 4/3 of pi times the radius cubed. So in this case, 1/2 times 4/3 pi, and then the radius again is 0.8 meters, and then we're cubing that, just like we squared this, and we squared that. All right, so let's try that out. So let's see, let's do this. Let's do 4 divided by 3 is 1.33, and we know that half is 0.5, so we multiply that by 0.5, and then we multiply that by pi, and then multiply that by 0.8 to the 3rd power, and we get 1.07. cubic meters. So the total volume should be all three of these added together, right? So total is 3.62 plus 0.47 plus 1.07. So let's see what we get with that. Hopefully it's 5.2 meters. So we got 3.62 plus 0.47 plus 1.07. And we get 5.16. Oops, sorry. 5.16. Which rounds to 5.2 meters cubed. So, yay, we got that one right too. Alright. Last one is problem D here. And it says that the grain has a density of 0.8 grams per centimeters cubed, and the density of steel is 0.8 grams per centimeters cubed. Find the weight of the silo when it's full. Okay, so remember that, let's see, it was density, right? Let's look up our density formula here. And that is density equals mass divided by volume. So density, oops, let's try that again. Density equals mass divided by volume. Okay. So if the grain has a density of 0.68 grams per centimeters cubed, and the density of steel is 8 grams per centimeters cubed, find the weight of the silo when it's full. Alright, so let's see here. So let's first figure out how much all the grain is going to weigh, because that's what we're looking for, is weight. Right? So the grain has a density of 0.68 grams per centimeters cubed, and it had a total volume of 5.2. Well, let's just go with their answer here, 5.2 cubic meters. And we should now be able to figure out what the mass is, right? Because that's over 1, and we just multiply this times this, divided by that, and we get that the mass is going to equal, let's see, it's basically 5.2 times 0.68. You divide that by 1 and you still get the same thing, so 3.5, let's go with 3.54. Right, and that's, I guess, no, it's not grams, certainly not grams, right? So that's going to have to be, that's per centimeter. Let's see, that's going to, okay, we actually need to back up here because this here is in grams per centimeters cubed and we have meters cubed, so we have to convert first. It's just going to make our life easier, so let's do that. So we have 5.2 meters, let's do this over here, 5.2 meters cubed. So we're going to convert that into centimeters, and it's cubed, we have to move over twice to get to centimeters, but since it's cubed we have to actually do that 3 different times. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So it's really let's see, 1, 2, 3, 1, 2, 3. It's really 5,200,000 centimeters cubed, and then that's going to give us our mass. Right? So we do this. Sorry, so we got to multiply this by this, and that's going to give us our number of grams for our mass, right? So the mass is going to equal, so let's turn this back on. and it's 0.68 times 5,200,000, which gives us 3,536,000 grams. All right, which will then just turn into, let's turn that into kilograms. 1, 2, 3 back, so 3,536 kilograms for the total amount of grain, the grain weight. Okay, so we also have to go back and calculate how much weight the all the steel is going to be. So so we know that there's 15.7 square meters of steel. So let's use that. So we have 15.7 square meters of steel, and let's see, the steel is 8 grams per centimeters cubed. That's the density of the steel. Okay, we also have to keep in mind with that the steel way back up here at the beginning says it's 3 millimeters thick. So we've got millimeters here and we got meters here, and we ended up with cubic centimeters here. So let's turn everything into centimeters maybe. So let's turn this into, so to go from meters to centimeters, we've got to move it over twice, but again it's squared, so we've got to do that 2 times. So it's 157,000 square centimeters. Right, and then it said that it was, we also had 3 millimeters, thick is the steel. So we got to move that into centimeters also. So that's 0.3 centimeters. So we multiply that by 0.3 centimeters to get our total volume of steel that we're using. Okay, so we do 157,000 times 0.3 gives us 47,100 cubic centimeters of steel, right? So that's our total volume, and again we know that the density of that is 8 grams per centimeters cubed. So let's do this. Density equals mass divided by volume. So density equals mass over volume. So in this case, the density is 8 equals our mass divided by our volume, which is 47,100 cubic centimeters. And again, thankfully we're already in centimeters cubed here, because this is grams per centimeters cubed here. So we're just going to cross multiply like we did before, and really that's over 1, divide by 1. So we get that the mass is going to be 8 times 47,100. 8 times 47,100 gives us 376,800. And that is going to be grams, so we move that back over 3 spots to get back to kilograms. So mass is 376.8 kilograms, right? So we have those, we have this mass here, and we have this mass here. So this is the grain, this is the silo, so we just got to add those two together. 36 plus 376.8, and get a total mass, that's whatever that is, added together, right? Isn't this fun? This is a long, complicated problem, but man, you figure this out and you've got it all figured out. So 3,536 plus 376.8, and we get 3912.8. So let's just call that 3913. 3913, and this is all kilograms. All right, so that is our total mass for that thing there, and that was one problem. Now, granted, the rest of the problems on here are not going to take that long as well, but anyway, that's how you do that problem number 2. Okay, so now you should be able to say that I can use various formulas and strategies to solve more difficult real-world type problems. Okay, and again, that's definitely the trickiest problem that you're going to run into. Okay, if you have questions, please feel free to ask. Thanks.